Hello everyone. This is Ben from Creality. Today, it's our honor to invite Luke join our live to build the 3DPrintMill, and also with our forum operator that Kevin. To say to everybody. Yeah.
Hello everyone. How are you? Okay, we got some audios. And
yep, getting audio feedback. So some of the people in the feed are obviously familiar with me and my work. For those that are going to watch this later, I'll sort of introduce myself. My name is Luke Hatfield. I'm one of the, I guess you could say, lead admin for the Facebook groups. I'm known for my help guide and a little bit for helping out with some Creality engineering and testing. So we're going to set up and assemble the CR-30. I do come to the table with the advantage of, I've assembled, dozens of printers. Part of that is I've got some Amazon returns that I'm turning in the background or whatever. So I set up a couple a week. But anyhow, I want to give you sort of the experience that I'm going to have with it. I haven't opened the box. I'm going to show you some of the tools that I got set out that I prefer to have when I put it together. And we can sort of all learn together what the unboxing and assembly looks like if you're not prepared ahead of time. So that's what we're planning on doing. We'll have Ben and Kevin taking questions from the comments. I have a remote camera. That's this one here. Yeah, it's not a great view right now, but once we get the printer sort of here on the table, I can move it in so you guys can see a little closer, hopefully. I am not a professional podcaster, so I apologize. I'm not going to have a Zoom cam, and I don't have one of the overheads like some of the other guys do. So you're going to have to put up with that. But anyhow, welcome to our little adventure here. Cross my fingers, everything goes smooth. It did travel over from overseas, so there's always a potential that something got damaged in shipping or whatever, but we'll deal with that bridge if we come to it. But I'm going to go ahead and open her up and we'll get started.
Yeah. Okay, hi Number. Thank you so much for joining us today. Yeah.
I haven't watched anybody else's unboxing in case you guys are wondering, so I don't have a pre-planned way to go about this, so we're just going to make it work. What did we name this little guy? What's his name?
Cool.
that's Lua.
Yeah. So he comes. You got some nice little stickers, your inspection certificate, all that fun stuff. Some of that filament. I don't know if you guys. It used to be CC Tree that made this for you guys, but I don't know if you're making your own or if it's theirs. But your 200 grams of filament that comes with it. You got the toolkit bundle that has all the zip ties, the flush cuts. Looks like it's got the nozzle wrench and a feeler gauge. What else is in there? There's probably a nozzle cleaner in there, if I know things, and a little screwdriver. So we are not going to use much of that other than maybe some of the zip ties, because I've already got some tools laid out. So let me show you a couple of tools before I put everything on the bench, because I won't be able to get at them. All right. So we're going to go to the second camera here, hopefully. Maybe, Ben, you could make that one bigger or something.
Yeah.
Just for a second. We're learning together here, so bear with us. So I've got a nozzle wrench that I stole off my CR6 SE. I love this nozzle wrench, by the way. It's really handy for the 6mm nozzles. Same thing with the 8 and 10mm wrench. I have, because I have a wonderful benefactor that has associations with Fabrico. I have these really nice hand screwdriver Allen wrench set, and then I also have a bigger kit that has nut drivers, more of those same kits. It has a little deeper thing, some nippers, and whatnot. But anyhow, those are the primary tools I have set out to use. I do have some lubricant. This is my preferred lubricant. It's the 3-in-1 brand PTFE liquid. It will not dry up and gum up and affect your Z-rods down the road. I have a set of calipers. I use using the cheap Tack Life ones. I do actually have over here on the table some nice Michitoyo ones if I really need to get super fancy with it. But right now we got those laying out. And because I always do my own PTFE or whatever, I've got a little cut tool to be able to, for my hot and fix that I'll use to probably trim the ends of whatever PTFE I put in. And I think I'm pretty sure this is original Capricorn here that we'll probably put on the machine as part of the setup process. All right, so now that we've done all that, sorry, I got to move stuff. I got too much
Hi, I'm
stuff in my
Edward.
way.
Nice to meet you, Steven.
Okay, this is what everybody else wants to see. So we got some other little stuff in this upper cavity. Nope, we go to this one. So this is a series of packages with nuts and bolts and T-nuts and whatever that we'll be using. There's a power cord. We won't get to that till later. There's a kit with the extra optical sensor. I'm assuming that's an extra. A lot of times, at least for the beta people, we get an extra sensor just in case something got damaged in shipping so that we don't have to send back to China if they're not openly available. Okay. Hey, the Creality filament spool. What else we got here? Okay, so we're getting ready to pull out. Oh, hold on, one more pull-out panel here. So we got some PTFE. We've got some fittings, and we have the SD card. Pretty traditional fare there. Now I'm going to figure out if I can get this upper assembly that's in here out without having it attached to anything else. I'm not sure what's wired to what, and I haven't read any instructions. Here's a pocket full of extrusions. I'm sure that I'll have to get those here in a minute. I'm guessing those are the arms that support the gantry held off of the bed at some point. So I got some cables going down and through there. And just for my own safety, I'm going to take the X stepper off of there for a minute. Or is that going to help me? No, it's not, because it's attached down below. All right, be prepared. You're going to have to hold on to this or have somebody else hold it. And have them, oops, one more part left in there. Have them hold it while you get that other foam out. And it looks like I'm going to set this on top of the other part and just pull it up in a big pile. Not very tidy, but it should work. Definitely have somebody available to help you out with it.
It looks so heavy. You need some help?
Yeah, just reach out and help me there. Okay. All right, nothing left in that tray. So I'm sure that some of my friends got a really big kick out of that. That's the way it's going here. All right, so we get it onto the table without killing ourselves. I'm going to get rid of this big old box. I'll try not to get my cement down while I do it. Okay. So, move this over just a little bit. Take the screen for a drag. All right. Okay, since we're doing it freestyle here, I'm going to see if the manual has really good directions in it or not. No judgment, right? After sales card, warranty. All right, we have directions. And just for you guys, I'm going to read them instead of just freestyling through it. So it shows it fully assembled. Here, you can look alongside me, I think. Turn you down a little bit. Or get you turned so you can read it, sort of, kind of. Hey, there you go. All right, it's showing the sub-assemblies, the display, all that stuff. And then we go into assembly. So it looks like we're going to start by placing the 2 rails that I pulled out by hand earlier that have the brackets pre-mounted on them. We're going to put it on the back end of the machine. So because we're working on that end, and I didn't have ESP and didn't check beforehand, I'm going to turn the machine around so we can get the camera close enough you guys can watch what I'm doing here. All right. Okay. Oop. That screen's going to be the death of me, I think.
You need a bigger table.
Yeah. I probably could have set up to do this a little bit better, but let's go ahead. Do you want to turn the upper camera down too? So we can sort of get 2 angles on this thing?
Yeah.
Let me see if I can.
I think it's good choice. We use that 2 cameras, so it kind of cover the whole.
Hey, guess what? I can do the top down with this one.
Yeah.
Cool. So let's see if we can get you a decent shot of what I'm working on here.
Yeah. So now you have camera from the top. So.
Yep. Then this one, you don't need to see the instruction anymore. So we'll give you a double view of what I'm getting ready to put on here. Sorry, I don't know where I put my razor blades, otherwise I'd be cutting through this already. You got to be multi-dexterous so you can get your way through the plastic film if you don't got your razor knife handy. So there's one. Just like Christmas. And the other one. Okay, so I'm going to look at the instructions here. I see in the instructions that part 7 actually has a place where there's a, looks like the filament run out sensor is mounting on it or something. So are these numbered? This is where you get graded, Ben.
Yeah.
You get parts numbers, but you don't put numbers on them, and if you can't tell in pictures.
Okay.
So part number 7 has something shown being on it.
Mm-hmm.
So I'm going to go with the one that has these little parts on it, being part number 7. So we're going to put that on that side and this on this side.
Yeah, I think maybe when they disassemble it, they just forget to tag the.
Oh, you know what? I turned it around backwards. Anyways, I saw these tapered extrusions, and I just assumed that this piece went on the tapered part, but it goes on the other end. So we're going to turn it around one more time. Okay. This is fun.
Yeah.
This is what it really looks like when you don't get to see behind the scenes. Right?
Yeah.
Okay. So this one's going to go there. This one's going to go over here. And I'm going to find the screws that screw those on.
Look, there are questions here. So what print are you looking forward to print with this CR-30?
So I've been thinking about it a little bit. So in the past, the Benchy is sort of supposed to be your first break-in print with things, you know. But I think for the CR-30, it should be a sword, because these things can make really long swords, right? That being said, because of brevity of time, I am probably going to slice up like a mini Zelda sword, just so I can do a sword first. And then later on, you guys can catch me in the groups. I'll put up some pictures of the big swords that I make. But that's sort of where I'm headed with it right now. My wife just got home, folks, so my dog is going to do some winter whining barking. My apologies, but she's a little chihuahua and I can't stop it. So, just trying to make sure I got the right screws here because I didn't read the rest of the instructions right. All right, so this is actually using shorter screws, hexagon screws. The 12 millimeter hexagon screws. So you saw it here first. Luke actually followed directions.
Yeah. I think that's the BB3 mentioned that what Poach did. So I like to share you a video here that it's really funny. So about CR-30 that I think
okay.
Yeah.
Okay, go ahead and run it. I'm just going to be putting pieces on as I go here.
Yeah, so you guys will see that what's going on here. That so it's really interesting what he did. So
yeah, you could if you want to. My wife once said, "Welcome me home."
You're welcome me home.
Yeah, because I've been traveling.
So okay. We can collect the finished parts easily.
Don't do what I did and drop the extrusion. Okay, so I'm finally getting around to putting extrusion on after all my distractions. So, for those that attempt to turn it into a actual build video, these are the M5 by 12 socket head cap screws. They're actually button heads. But either way. So I'm going to put these on, and I don't know if it specifically says it in the instructions, but anytime I do a whole assembly, I am not going to tighten those all the way until I got all the pieces together. And there's a reason for that, because it can actually cause problems with the squareness of the assembly if you start tightening stuff out, because you have tolerance in the holes and things can get screwed down and then bent or flexed or put under tension, and that doesn't make for good quality prints. Okay, so we got those two pieces on. It shows that filament sensor being up on there. I'm going to throw it up there really quick, but I think this is the wrong time for me to be doing it. We're going to do it anyways. So we have the sensor. It's going to mount up here. You can see my neighbor's house. They've hi to the neighbors. Here in a little bit, we'll probably close the drapes up and whatever.
Yeah.
But anyhow. So what is it showing? How is it showing that sensor being on there?
Yeah, this Brian said that's what he did. He left all the screws kind of do everything.
Yep. And for the moment, this is going on the side. I don't know where it actually is going to line up with other stuff at, but we'll find out here in a little bit. So, yeah, the trick to those T-nuts is loosen them most of the way up and then spin really, really fast to get them to lock into the slot. There we go. It's there for now. All right. Let's see, is that top down working good? I'm sorry, I haven't been keeping track of it. I'm going to go up more, up and back, and tip it a little bit.
Yeah.
All right. So, what's it want to do next?
I think Astro Printer is I don't know if it's a question or not, or a joke. He said, "Look, instructions. Where are they? I heard the come with printers, but the paperwork is just extra padding, right?"
Yeah, exactly. And for honestly, if I wasn't building it for you guys or whatever, I'd have gone at it willy-nilly and just put it together. And I would have looked at the instructions if I got jammed up on something. All right, so I got my bigger nut driver. So these are, for those following in the instructions, we're mounting the XY assembly up onto the back here. And we are using a couple of the M5 by 12s again. And then these M5 by 45s, the really long guys, those big guys, to hold the extrusions on. And then we're also using some shorter M8 cap screws as part of this. So, so for right now, I'm just going to sort of set that bridge up in place and get a couple of the long screws in, and then we'll go from there. So,
Look, no questions.
the other thing to look at, I'm sorry, what's that?
Why isn't blue Loctite used on all fasteners?
For many reasons, one of which, and don't take this the wrong way, Crypt Keeper, but a lot of these button head cap screws, if they get over tightened at the factory, we have people strip them out without even putting Loctite on them. If they put Loctite on there, that could create really serious problems for people. So I'm not a fan of that idea of having it done that way.
Okay.
And for those taking notes, there's this wiring harness that runs back into the side here. I'm pretty sure I want it up and over this extrusion when it ends so that it isn't coming down into the work volume area, because this other part's going to have moving stuff around. So I am putting it up and over there. I probably could have unplugged it later and rerouted it, but you want it on the outside of this assembly when you get there, however you get there.
Also, I think, look, finally, people have attention on your extra printer box.
Okay, yeah. So I didn't say a ton about that. So I am acquainted with a US-based Amazon seller who gets user returns, and he was having such a hard time finding people to take the user returns and fix them or whatever, that I agreed to buy large lots of the printers from them. And so I buy them, I refurbish them, and I'm selling them locally. If you want to contact me and you're within a reasonable drive for you to the Vancouver, Portland metro area, you can contact me later and see about purchasing one that's been assembled by me. I've had a few people that were really excited to find out that they were buying a printer from the Luke guy from the Facebook groups. So I don't know if that's you, but if that's you, contact me. I have, I don't know, I think I got 12 printers on hand and another 18 coming that will eventually be put up for sale. I got a mix of Ender 5 Pros, CR6 SEs, Enders, Ender 3 Pros, and Ender 3 V2s. It's pretty much the types that come through. And just for Creality's sake, because I think it's worthy of mentioning. For those taking notes, I'm taking that big long 5mm, and it goes down through the end into the main extrusion. But probably 85% of the ones that I get back as Amazon returns are what we call open up, scare, send backs, right? So I'm opening these up, and 85% of them, they never even took the parts out to try and assemble at one time. So if you're new to the 3D printing thing or whatever, and you think you might become one of those people, there's plenty of videos to help get these things assembled. You don't have to be a rocket scientist to do it. I have not to offend the people I'm going to mention, because they are all nice people, but they're all not mechanical people, right? So I have had grandmothers, mothers, young teens, preteens, all put these things together and get them running. As long as you're willing to, watch some videos and take your time, maybe find my help guide or another assembly process that suits you, and you can do it. There's no reason you can't put it together. All right, so let's see, 20.
Look.
I'm sorry,
Also, a quick question here but it's kind of interesting one.
Uh-huh.
So you're trying to break the record what Creality holds for the 10 meters print. I don't know if you have 10 meters print. Yeah.
Yeah. So here's the deal. Somebody using one of these is going to start setting new world records for the longest continuous print. And I've already put some thought into it. I don't want to be the guy that's 20th down the list on people that held that record. So I'm not going to do that. But that being said, we might make some really long things because I've got a pallet 2 that I can put in bulk feed mode. And we can run this thing continuously as far as I can support parts without breaking it or messing the part up. So we'll probably play around with making some pretty long stuff just for fun, like maybe make a piece of crown molding for my house or something fun like that.
Okay. So when you said palette, you mean that multicolor?
Yeah, it has 4 spool inputs on it, but you can use it in what they call bulk feed mode. So it sends the printer drags the filament through and it keeps providing it. And then when one spool runs out, it splices it and it keeps sending filament. So when that one's out, it has 3 more it can go through. And as long as you replace the other ones, it will splice them back in when it gets through with the ones that are there, right? So it can pretty much run almost indefinitely if it's set up right. And I haven't done it yet. So if somebody comes in and says, oh, there's something that stops you from how many times you can do it, I'm not aware of it. But as far as I know, I should be able to get it to set up to run almost indefinitely as long as you fill the other empty holes before the last one is used up. So that's one of the things I'm looking forward to playing around with. Okay, so we need those taking notes. We're on to the M5 by 18s. They're the longer button head cap screws here. Those are going to go through the side frame over here. Here, let me turn it around so you can see. That's part of the reason we're doing this is so you guys can see. I'll remember later whenever I'm so not worried about it. I'm going to move that filament though before it goes for a sleigh ride. Okay, so we'll move this camera over here. Let's see, what's the best way to orient that one? Make it upside down. And the other one looking at you. All right. So we're taking our M18 screws, M518s, and they're going to go right in here. There's 3 holes on this side and 3 on the first side. So just because I don't want to have to keep turning this thing around, you're going to see the first 3, and then you get to listen to me talk while I put the other ones in. And move that out of the way. And I can't even see if I'm lined up. There you go. Oh, you know what? Let me turn off my phone so you guys don't have to ring every time somebody texts the chat. I am not being a good podcaster or whatever you want to call this. There we go. All right. Anyhow, but I am looking forward to some of the cool aspects of this printer in that you can set it up and potentially just keep rerunning parts or whatever in a loop. Okay, so we got that screw in, that screw must go in. Okay, so I'm just taking these in until it's barely finger tight them. Because here in a little bit, I gotta figure out what I want to try and square here, right? So on a traditional printer, I'm checking to make sure this is square, that everything's racked this way. And because I haven't dealt with this printer before, we're gonna have to figure out which way.
Luke, sorry to stop you, but the quick question here. I think this is a really good question. So honestly, I just want to know if this thing really works or if it's a maintenance nightmare.
All right, so you're gonna have to hold on for the long term on the maintenance part. That you get down to brass tacks. Most of the gear on here is stuff that we've used before with Creality. So it's proven technology. if you want to say it that way. And about the only thing I'm really unsure about is the longevity of the belts. And we can all learn that together. I know that Creality was not happy with how the first round of belts went. That's why there's a lot of upset early CR-30 Kickstarter backers. But the people that were upset about being held up, it was because they were trying to make sure they had good belts when they went out. So, you know, for my part, for Creality, sorry for your wait, but it's better to get it with a decent belt on it than have something that works than not, right? So they were doing it in your best interest, even if your anticipation was killing you, right? Okay. So those are on sort of loosely. The other ones are on loosely. I already did this part and the other part there. Okay, now it's showing me to put the spool holder on this side here before I mount the screen. That sounds like a good idea because you aren't going to have much access at it later. Now, it shows the little clips on there for this part, so I got that part right. Oh, you know what? Those clips are for wire holders. Okay, that's why they're there. That makes sense. Okay, so we're going to put the filament spool holder on here. And at least according to that picture.
Yeah, Martin said, unfortunately, I only got the returned is unnecessary 2 printers, and one was totally trashed, and one the bed was smashed but never used. I'm sorry to know that. But I think if you still have printers, you may just join our official group and look at it in the group and maybe see our other members or admins will help you out.
Yeah, so it is a mixed bag on the return ones. Like I got one time where they put everything back in the box with no padding or anything, and it looked like you ran it through a rock tumbler. That one obviously wasn't as nice as some of the other ones. But that's the deal. If you're buying user returns, you take what you get. Most people know I really don't even need the money for those. I'm more helping somebody out. But my son is off work right now with COVID, so he's making a little extra money helping flip the printers or whatever. So in that way, it's been sort of a quote unquote godsend. But either way, we're doing it. We're having fun. Some of the local people are getting printers at a discounted price, and keep it moving. All right. So get our little T-slots to line up in there. Okay, there we go. And I don't know that matters specifically exactly where that thing is at.
Look, we have a question here. I think it's also a practical one. My 3D Maker's Hub, his question is, would there be how much room do he need realistically for this CR-30 workspace? So.
Okay. Well, I'm looking at it on my bench here, and I'm going to say that this thing's, without putting a tape on it or whatever, it's probably about, 700 millimeters deep. And then on the outfeed, it's just has to be enough distance in front of it to make your parts, right? So if you're making parts that are short that fall off into a catch bucket, you probably only need like 900 millimeters with the space in front of it to fall off. If you're printing a broadsword that's 2 meters long, you're going to need a lot of room. So yeah, that's how that's going to go.
This these 3D prints that just had a weird, so I wonder how to Oculus will look with the CR-30. Doesn't seem too practical since the print is always moving away though.
Oh yeah, you're talking about the filming with the Optolapse. As long as you got your camera set up in the right place, it'd be sort of interesting to watch it.
Look, sorry, stop you. Could you just adjust a little bit of your angle of your camera? Maybe people can see you what you are doing now.
Okay, I'm sorry.
Yeah.
I was over here. Oh, my bad. I'm being a bad host. So I was just over here. I was just putting the filament spool holder on. It goes right next to this little bracket that is there for wire looming. I'm about 100% sure on that right now. So I assume at some point these wires are going to come over here and they get held in that loom somehow or another to get from point A to point B. So that is sort of thoughtful that they put zip tying points in, but I hadn't quite got that far on stuff. Okay, so we're following the directions as we go through here, right? So we put the spool holder on. So we're going to the next page. Step 4, install the display so it gets the other 2 T-nuts and the 2 more of the M8 screws, little guys here. And how does it look? Oh, it goes on the face of that extrusion. So these are going to go through the hole like that. My wife's going to hate me because I'm fixing to take off the... There we go. I know that some people get really weird about taking plastic stuff off. Anyhow, so... And when you do yours, don't be dragging your screen around by its wires if you can help it. That wasn't really a preferred thing for me. I just didn't have planned far enough ahead of time to not do that. It should be a testament to the wiring that it held up or whatever, but probably not the thing you want to do with your nice new printer. Okay, so and those taking notes, they've run a really nice bonding wire to this for the electronics. That's in my opinion, a big plus. And if you can see it, I'm fixing to plug the plug into the machine here in a second, as soon as I figure out where it's going to land at. All right, so this is going to end up right here. I did that mainly to make sure I wasn't putting my wires in a bind when they got to their final position before I put the plug in, which I'm fixing to do right there. Okay, plugs in. And I don't know that it really matters what height you put the screen at, but can you see me? Okay. I'm sorry. Here.
Yeah, we're seeing you very clear. And I think his Chinese name Mu Jialong, so he can say that his whole print farm is Creality printers, and he's a huge fan. So if he can rely on this 3DPrintMill printer, he's totally going to buy one. But I think he's looking forward to a review after several months of use. It should be you, yes, I think.
Did I drop that T-nut off? Is that what happened? I did. I'll get a kick it out of that in the later stuff. Oh, there it is. My T-nut fell off the screw, so I'm having to improvise here. So let's see if we can actually get this in frame, and so you guys can see what I'm doing. Okay, so what happened is the T-nut for the lower screw went down the extrusion, was sitting in the bottom, and I need to get it back up top. So I'm going to stick a screwdriver in there and hopefully push this thing up until I can get my screw into it, so I don't have to take it all back apart again. And lo and behold, it worked. All right, so we got our screen mounted. So right now I still have a bunch of loose stuff. You can see how loose that is. The main frame has been tightened, or not tightened, but attached at the lower section. Here, let's move back here a little bit so you can see everything. So these are just barely snug, but we got everything together. Nothing is bound up or anything like that. I am not seeing anything in particular that I can do till later, like if I put a tape measure on things to square things up. So now I'm going to go through and start snugging everything up. So I will start with doing the ends of these extrusions out here. Tighten those up. And we're only making plastic parts with like not even a couple Newton meters of force between the nozzle and the head. So you don't have to turn these things until you break them off. They just need to be pretty snug so they don't rattle loose over time.
Yeah, and I think Crypt asked, will there be a quad cameras released for the Wi-Fi 3D printers where they have a proprietary plug, or will any cameras be able to be used? Maybe Luke first answer as far as you know, and then answer from the company.
So Creality Cloud has been upping their game on what they're doing. But I don't know when they're going to have the cameras available, but I would anticipate that they will become available sooner than later. I had to change out wrenches. The set screw in one of my wrenches came loose. That's why I had two. Okay, so I've tightened these. I've tightened the ones on the far side here. Now there's two more up on top. We'll tighten those. We got one going through here. The top to tighten. And then there's a larger screw on the other side into the main there. Tighten that up. Okay, so now since I got one half of it pretty secure, I'm going to pick it up by that half and turn it around so you guys can watch along. Okay, so I'm going to go to these lower screws. Are you there? Yeah, you can see. So we're going to do these triple screws here, tightened up. Then we're going to do these two over here on the back side. My audio went quiet. Did you guys drop out? Oh, they muted themselves. Okay, we're good. Just want to make sure the stream didn't die. And then we take the big wrench and we go up top again. Up here, tighten that. And then there's one other screw right here. All right, so another day I'll have to sort of put together in my notes about how I might go about making sure that this frame is square and that there's no skew in this. But for today, we're following the directions. We've got all those things put together, everything's snugged up. I'm going to guess that the next step is probably going to be start to hook up some wires, but let's go to the instructions. See what it says next. Cable connection. Hey, how about that? Okay, so it shows us we got the power cord. It shows us to hook up the screen, which we did as we put it on. So we got to put up the Y-axis limit switch. Let's see if we can get you a good picture of that. We got to turn it around again. I'm gonna manhandle this thing a bunch of times tonight. Hope you guys appreciate it later. We'll see. Okay, so we're down here. We have the connector here that needs to go to something to run the Y-axis optical end stop. And I'm going to see if I can figure out where its other end is at. It's probably on the bottom. So now that we got it more assembled and more rigid, we can tip it up and look for the other half. There it is right there. I'm going to choose to go on the outside of the frame with it, just so it doesn't happen to get over into that drive assembly later. This is a precaution. I don't know if they show that in the directions, but if they didn't, they should. So, yeah, we're hooking it up on the outside here. Just trying to figure out the directionality of the little plugs. Oh, so I'm not going to be able to zoom in close enough for you guys to see it, but there's a tab in these connectors. Make sure you have the tab on the male end lined up with the slot on the female end, or you can jam your pins on your sensor wires. So that's connected. What other things? So we've got the Y limit. It's showing to put the Teflon tube in, connect the broken detection line. So we got to plug in the Filament Run Out Sensor. So let's go up here. So it shows putting the PTFE in. but we're going to do something with that here in a minute. We're going to replace this PTFE for more than one reason, and I'll get to that in a minute. Okay, so what else does it say here? So then it goes into adjusting the eccentrics and leveling. But Ben, not that they're going to fix it tomorrow, but they left out quite a few of the wiring connections. They are basic connections, but it's not in the book.
Oh.
So we'll do it here in the thing. So we know we have an extruder that needs powered. So E on these wire cables is going to be for extruder. It lands pretty close to where it needs to be plugged in, so that makes that pretty easy, right?
Yeah.
Let's see, let's do that. Okay, then I have the Y-axis motor wire. So that's the Y-axis motor here. So we'll put it up in there. These do have that sort of a raised portion on it. The raised portion goes to the open side of the pins on the connector. And be careful with these. If you bend those pins, they can be straightened out, but if you bend them too much, they'll actually break off, and then you're not going to be a happy camper because your new toy is going to be broken.
Yeah.
Okay, so the last wire that I see that isn't connected currently is the filament run out sensor that's sitting right here, and its connection is on the back side. Similar deal. It's got a lugged key connector to hook into, like that. And I guessed all right with the location because it's right in line with the extruder release arm. So that looks like it should work. All right, so time for another critique thing here, Ben. So this is something you guys get to see as I do my process here. One of my complaints would be in how this was sent out currently. This, here, let's bring the overhead right over the top of it. Let me get that up over here. So this is making, there we go. So this comes up and makes a twisting turn out of there.
Yeah.
That filament is going to get dragged right in that sharp radius that's formed right there from the way it's shipped. We're better, the customer's better off, even though we know that customers aren't really comfortable with putting the PTFE in on their own. I think that they'd be better off to not have it installed in a loose circle and then have them put it in, because this is going to cause under extrusion issues if it starts hanging up on that tight radius bend that happened right here.
Okay.
So, okay, so this is where I start freestyling a little bit. So on my Ender 5s and like that, I have what I call a filament support arm that comes out and above to hold things. And I actually have one that's really close by. So give me 1 second. Sorry about this chair. Noisy chair. But I am going to set up my support arm on this thing so that it holds the wire weight and the wires aren't connected to the PTFE anymore. I personally just don't like that setup. So this is available on Thingiverse as it's the overhead support for the Ender 5 and others or whatever. So we can sort of clip that thing on there like that, and it'll sort of act as a wire support. I might have to get a taller one just for the height because I have some that are powered. But for the moment, this will have to work. So I'll put that little clip on there to sort of keep the wire up and out of the way. Okay, and then now I need a pair of flush cuts so that I can take off those.
Look, so I will just share your Thingiverse link. So anybody interested could just download and use for your own computers. It's not only for Ender 5. The Look have many versions, so you guys can check out. And also in latest D1 or Summon D1 printer.
Yeah. So that'll be an L3D help guide on Thingiverse as overhead support. And you want the medium. This is the Ender 3 version. The medium one will be taller and reach out a little bit more, but it'll be almost perfectly centered on the on the work platform when you get done with it. So I'm going to cut these retainers off for the moment because I want to put new PTFE on there because that one's bent too harshly. I guess you did send extra PTFE in the spare parts, so if you got one that shipped beforehand, before this stuff gets integrated, there is a tube that isn't all kinked up as bad as that one is in the kit, so you can use that if you need to. I personally am going to use some Capricorn. And let's see here. So I'm pulling off the clips that hold the, I'm sorry, what?
So Crypt asked that is there anything new or different with the extruders in these new releases? So I think you will answer later, right?
So this extruder is the dual gear, like we put up, like I say we, like you guys put on the CR-10, the CR-10 Max, the double gear extruder. It's a really nice extruder. The only known issue long term with these extruders is right where the idler gear rides. It can cause a wear in the arm, so you got to keep greasing it really well so that it doesn't cause under extrusion. But usually, as long as you keep it greased, it'll do a little bit of wear. It'll wear in, and as long as it's greased, it runs great. I'm still using mine. I just had to grease it a couple of times, and it works. Not ideal, but it never quote unquote broke or anything. It just had a little fit there for a minute. Okay, so I'm currently taking off the Bowden clips. People often go, what is this, right? Can I get it in the right camera? Here. The little blue clips. You know, so I'm taking those off so I can take the filament out. For those that haven't worked with these before, it's what they call a push-pull. Here, let's get you back up. I'll move this up here. Can you see that? All right. So we do a push and we pull, and it came out. And then on the other end, it's into the hot end. Depending on if they hot tested this hot end, it may or may not come out without being heated up. So I'm going to push in on that collar and pull, and it won't come out. Okay, so to get that one off, I'm going to have to actually take the housing off to get it out. You don't have to do this, but I prefer to use aftermarket fittings for my Bowden fittings. So I'm going to take these stock ones off. They get them out the door, but I just replaced the fittings for non-good fittings. Now these ones are, for those that have been complaining about not using metal tooth fittings, I don't know if we can get that thing to focus, but it almost focused there for me. These are metal tooth fittings, so they're better than what Creality used to use, so that's good. So you don't have to replace these, but because I have some from a source that I've been using forever and I don't want to have to think about it, I'm replacing mine. So was that a 10 millimeter? So I'm going to put my new one on there. People are going to ask who makes them or whatever. I think it's the BQ brand or whatever. I'm going to put that on there and go in until it sort of snugs up. You don't have to kill it, but it does have some PTFE in the threads, so you want to go in until it snugs up. There we go. So that's on. And so now, before I get too far, so you're going to watch me do something that you got to be really careful about. Okay, so right now, just from the way that things came assembled, the workhead is almost down to the touching the bed, and I want to bring it up so I can work on the hot end assembly. So what I'm going to do is slowly start moving this thing up the carriage a little bit, and this is going to show me that I probably need that other arm sooner than later because I just don't have quite enough vertical clearance on my stuff. But yeah, I guess for the moment I can take that off because it's just in the way. That's the nice thing about those click locks. Get it out of the way. Okay, so I am going to take off the fan housing so I can get a wrench on the Bowden fitting there. I'm going to take the PTFE out and the fitting out. You don't have to take the fitting out, but if you're messing with the PTFE and it won't release, like this one, I can't get it to release. You're going to have to take the shroud off to get at it. So let me see if I can find the right Allen wrench for those screws. Do be careful with these particular screws on the fan housing. It doesn't feel like these ones were over tightened, but we often have users strip those out if they're not careful, because they're a shallow headed screw and they get rounded out pretty easily. So take your time getting those out. And let's see. Oh, there's multiple screws. So there's 4 screws. So for those wondering how many screws it takes to get the pound shut off, it's 4. There's 2 on the upper and 2 on the side.
Yeah. Look that the 3D Mix Hub that he think he would relocated his motherboard to the top of the 45 can where you put cable helper and run power up the left Z.
Yes, I suppose if you wanted to, you could. I rarely move stuff around unless there's an engineering purpose for it. Like if I didn't think the fan was getting enough, the PSU was getting enough cooling in here, I might pull it out and do that. But really, that's not the first thing that I would be doing, at least till you get to know it. But yeah, it could work for sure. I'm doing another clip here to just give myself some flexibility on the wires, because I don't want to break my new wires as I'm putting this around. So I'm laying the fan housing up and over now that clip is off, and I have access here. I think we can get up over that better. Let's see here. So you got to thank my oldest son Thomas for the nice positionable camera. He's got a swing arm camera he set up for his D&D stuff or whatever that I stole from him. So yeah. So I'm going to undo this, and depending on how it goes, it could still be stuck in there if it's been heat run and a little plastic stuck on it. We're going to find out here in a second. If it is, we'll probably fire it up here in a second and see about getting it out. Okay, so the fitting's up and out. And how stuck is this? Oh, so it came out. For those taking notes, it was tested at the factory. I don't know if the color is going to show that red filament in there, but they use red filament to test it. I see some people sometimes think when they take their filament, PTFE out, that because there's plastic in here, there was a jam. It is perfectly normal for plastic to be melted in the first couple of millimeters of this. The jam comes from if this and the nozzle have a gap between them, and there's a slug of plastic in there causing your extruder not to be able to push the filament through. That's the jam. It's not what's in here. It's what's in between the PTFE and the nozzle.
Mm-hmm.
All right. So we got that off. I've got my Capricorn here. We'll see how it sizes up. So if you wanted to do a factory match, you can just sort of pair the two up and bring them out and trim them to be the same length. Before I do that, I sort of want to take a look at the overall movement of this thing, and I'm going to determine if they use more than I want or less than I want. I know that I'm going to have my arm up here supporting, and I'm going to have the PTFE loose while the wire is held by the arm. So I just want it to have a nice free run to all areas of the work cavity. So in this case, the farthest place it's going to go is over to this corner over here. So if I've got that sort of at the extruder, which you can just barely out of frame, but trust me, the end's at the extruder, and I go over here to where it's going to do the furthest most travel, I'm going to cut it, and I'm allowing for it to go down through into the hot end and everything. I'm going to cut it about where my finger is at. I happen to have one of the fancy little cutters, so we'll use that to cut it. And then, depending on how well that cut it, I have that little box so we can sort of make sure the end is squarely cut. Here, I'm going to go to this side view here. So can you see it in focus? Here, I put my hand behind it and get it to focus. There you go. All right, so if you guys can see, that's not perfectly square cut, and that's not really a trash on the cutters, but the tubing was bent when I cut it and whatever. I want that to be perfectly straight. So I'm going to take and I'm going to relax this as straight as I can with my fingers. You sort of run your fingers opposite the curl, it'll start to straighten out. I'll get it nice and smoothed out. Once I've done that, I'm going to take my little cut gauge that I showed you guys earlier. And somewhere around here, I still have my box knife. Oh, there it is. So I'm going to take my little knife. I'm going to take my little gauge. I'm going to put the end through the gauge. And then I'm going to cut it. I'm going to put it on the table, and I'm not going to set the camera just to put it on the table, but just know that I'm cutting off the end to get it nice and trued up. This part isn't rocket science, but it does need to be done if you want really good results. Okay, so now, let's see if we can get it to focus again. Yeah. Focus.
I think you may take. Okay.
There it goes.
Oh, yeah, there we go. Yeah.
But now it's nice and square.
Yeah, that's good. Yeah.
And that end is going to go into the hot end. The other end is a little less critical on how square it is. So I am not actually going to put it down the hot end now because I want to heat it up. I want to take the nozzle off. I'm going to clean it to make sure that there's no plastic gets in between the PTFE and the nozzle. But that's going to take a minute. So I don't know where my son went or whatever, but here in a minute we can actually put the cord on it and fire it up for the first time, and I will heat up the hot end so I can do that. Did you have a question going?
Yeah.
Have I had a chance to play with the Ender 6? No, I have not. I've been supporting it. I do have experience with Cartesian printer, Core XY printers. I, in the background, have had them for myself. And there's, I can tell they did a pretty good job on it. The biggest key with any of those printers that are Core XY is to get your belt tension balanced perfectly between the two sides. So along that line, I've actually been mentally thinking about how I might deal with it. And I am sort of looking at seeing if I can set up a strain gauge with some Marlin code and setting it up so that it, based off of the Marlin code feed, tensions them to the exact same value with using like a extra stepper motor and that sensor to feed back. And if we can pull that off, then you can have a sort of automatically tensioned Core XY, and you won't have oblong parts. Because what happens is if the belts are out of tension between the two, so if one's got more tension than the other, your parts will be oval instead of round, which obviously is not very good, right? And that's just a function of, the one thing I didn't check, and I'm pretty sure that this probably has an auto sensing power thing, but let me look real quick. So those that aren't familiar, because we have EU and US, you can have either 230 volt mains power, or you can have 115 like I have here in the United States. Everybody in the United States has it, unless you're running it off of a garage dryer outlet. So don't tell me, oh, I burned up my outlet, so you're wrong. It can't be 230 in the US. But anyhow, there is underneath it here sometimes a selector switch to go between 115 and 230. And I am looking, oh, that's an interesting find. So I don't know what they were planning on doing with those, but there's some really cool magnets underneath of there. I have to figure out where those belong here in a little bit. But anyhow, so I am looking for the main selector switch. It's here on the front. Let's show it to him since we're doing all that talking about it. Sometimes they have an auto sensing switch. So let's turn our little camera down here. This little red switch right here. So everybody gets upset in the US that struggles with these because they go to turn it on and it won't turn on. And then somebody says, oh, duh, you got to turn the power switch from 230 to 115. The reason it's done that way is if somebody in Europe gets it set to 115, it will blow up the power supply. In the US, you just get an annoying, it doesn't turn on. So it's safer for everybody if it's set to 230. So as much as it might bother you because you didn't find out the easy way, it's the better way as a manufacturer to send it. So you can write all the letters you want. They're not going to change how they do it. Okay, so now I guess we can sort of leave it set up this way. It sort of works for what the camera's doing and whatnot. I'm going to move it over just a little bit so that both feet are supported on the table. We'll move this one back and up a little bit maybe. Or maybe we'll get a better look at the, I'm going to do it the hot end over here. Can you see the hot end? Yeah, there we go. Get the hot end sort of in the middle of the frame. Oh, there you go. I think you can see most of it now. All right. So what I want to do is I'm going to plug the power in. Now that I got that part settled out and my power cord disappeared on me. Give me just a sec. I got to reroute the power cord here without taking out the camera.
Look.
Yeah.
Someone said, I think Jude Nation said, Luke's desk looks messier than mine.
You ain't seen nothing yet.
Yeah.
But yeah, nobody will ever accuse me of being the most organized person in the world. But I'm okay with that. Okay, so as some people like to say, we're going to test for white smoke. So I'm going to throw the switch. It should turn on. You should get the screen lighting up over here. Unless I'm having a really bad day, and then you'll see smoke rolling out of here because something went wrong, and then we're all having a bad day because our day will be over. Throw the switch. And it's powering on. We got a welcome. It's got a CR-30 thing with a little belt feed image on there. We got version 2.0.6.3 firmware. And that's a lot of points. Okay, so it's turned on. Things to check when you first turn it on if you're not familiar with printing. Let me get this a little closer so you guys can actually see what's on the screen here. Going to get it to read it. Can you guys see that? Okay.
Yeah.
It's not clean enough, I think.
Yeah, I think focus is not kind of.
Not the greatest.
Yeah, it's kind of blurred a little bit.
Hey, is that better? It seemed like it got better for a second.
Yeah.
Okay. Well, you're going to have to take my word for it. So it says 24 degrees on the bed and 24 degrees on the nozzle. That tells me that the thermistors, the things that measure temperature on the bed platen and in the hot end, they're reading room temperature. If one of those says negative 14 degrees, that means that wiring has got unplugged in shipping, and you need to go find where it plugs in at both ends. Well, it only plugs in at one end, sorry. You have to go inside the case, and the wire will have unplugged out of the case. But anyhow, so if it says negative 14, that means that the one of them got unplugged in shipping. Much to some people's chagrin, they generally hot glue all of the connectors to the motherboard. That isn't just to make you upset when you want to change out motherboards later. It's because they had so many printers during the CR-10 days that arrived with wires unplugged from the forces from shipping, that it was determined it was better to glue those wires in so they didn't come out, so they didn't have upset customers. So another one you can not write them about because they're not going to change how they're doing it. Right? So get that out of the way. Okay, so but now we're gonna go for temperature for the nozzle. When I take off the hot end, I run it up to 250 degrees. So that's what we're gonna do now. Oh, evidently it's temperature limited to 240. So we're going up to 240 then. I'm sure that people reflash this with other firmware and go up above 240. I don't even know why they set it that low, but I guess they're really not intending this to run multi-materials, only PLA and TPU and stuff like that. But either way, it's a standard Creality hot end. It's capable of going up to 270 degrees. You just need your firmware set accordingly. I wouldn't worry about that. Okay. So it's heating up. They hadn't over tightened it at the factory, so it hadn't even got the temperature. I'm taking the nozzle out. Where's the camera? You see that little bit of smoke coming out? It's not a big deal. There's just a little bit of plastic residue in there. So what we're going to do is Luke is going to cut off a piece of this PTFE shorter. And we're going to use it to clean out the hot end. I am going to turn the tip down though, because we can go to, it don't need to be out to 200 to clean the PLA out of it. So I don't smoke the whole house out. We'll go down to 200 degrees. But anyhow, so I'm going to take my cutter. I'm going to cut off a shorter piece of filament. And we're going to run it through there to get any excess plastic out. So I'm going to show you what that looks like. So you can see, you want to switch cameras there for a second, Ben?
Okay, yeah, sure.
There you go. If I can get it to focus. Come on. If it'll ever focus, there's red plastic on the end of that. That was inside the hot end. If you get that between the end of the tubing and the nozzle, it's going to create all kinds of problems for you. So I'm going to run this through 2 or 3 more times. Make sure there's absolutely no plastic left in the hot end when I put the nozzle back on for the last time, at least for this session. Got a little bit more out that time.
So Luke,
go ahead.
So Luke, is this step is necessary for all the new printers, like Ender series printers?
Yeah. So personally,
because
this
I have
is my
done this step before my Enders.
Yeah. So personally, it's part of my process. I always do that.
Okay.
You don't have to necessarily do it, but if it comes from the factory and they didn't get it seated well, you'll have that void problem that we run into sometimes, where it causes under extrusion. And the only way to get it off is to. My cat loves those the foam in the boxes. She's over there tearing one up to shreds. But anyhow, so I always take them apart and clean it. It's just a good check. I mean, I know the factory's trying to do a good job of it, but you won't know if yours is assembled well unless you do it on your own, right? And it's a little daunting. I want to show you. Can you go back to the other camera for a second, Ben? So I cleaned all the plastic off of that so that there's nothing past the face of it.
Yeah.
So now when I put it in the hot end, nothing's going to get stuck between it and the filament, right? So I'm going to start it up into the hole with my fingers, and then I'll take the wrench and screw it up in there. So now I'm going to heat it up just for a minute back to that 240 because I want to tighten it as above my working temperature. So if I'm doing PLA, you want it hotter than your working temperature while you tighten it. So when it cools down, because it is going to come from 240 down to, I run PLA at 205 to 210, that cooling will actually help lock the nozzle even tighter, right? So this is a good process to use. Oh, so it overshot the 240 a little bit. So I'm going to go ahead and tighten that up. Pretty snug. It's tight. Now I'll bring the temperature back down. I'll bring it back down to 200 again. 199 because I missed a step. But now I can install my PTFE in there without having to worry about causing problems. And so what we're going to do, so I have what we call my hot end fix that I could be installing in this hot end right now. So we put a cut piece of PTFE in there with a plastic spacer that goes underneath of this fitting, just for brevity and to show you guys it works without using my hot end fix, and that I do know how to do it other ways. We're going to do it without it. So what I'm doing is I'm turning this fitting in until it's about 2 turns from being all the way in. I don't know if I can zoom in much better. Let me see. Let me get it over to where that can really show. We have many angles. Oh, sorry, I put the cover over it. There we go. Hold on. There's a stupid little safety cover thing getting in the way. Okay, so right here, let me get a better pointer. Get really fine detailed here. So this fitting is going to shoulder out almost all the way up against this. I have it out probably about 1 3/4 to 2 millimeters. I'm going to put the PTFE all the way in and until it's touching the nozzle. So we'll do that now. I'm going to push it in until I feel it seat against the nozzle. I'm going to take the clip. I'm going to clip it now before it's all the way tight. Okay. As long as I can get that clip to stay in there. And then I'm going to tighten it down. And what that's going to do is drive those teeth of that fitting into the wall of the PTFE and can create compression between the PTFE and the nozzle. So I won't have any possibility of getting a gap in there that's going to cause under extrusion. Right? So this is what I taught before I created my hot end fix. It does work sometime. Or not, I shouldn't say sometime. It will work when you put it together. Over time, those teeth will dig further and further into that PTFE, and you will get a void there over time. I don't care how well you do it, how much you screw it down. But for now, for the time being, for the short term, it won't have that problem. So now, let me take you back up here so you can see more of what's going on. Sorry, we don't have a camera test here. So you gotta bear with me as I remove you around. Don't get too dizzy on me. Oh, there we go. Back up. Hey, there we go. So now I'm going to put this other end into the extruder. Put its little locking clip on. And these blue clips are a little bit thick for these, but we'll make them work. Okay, so now we're actually set where we can put filament in here. And then we're going to run into a roadblock because I did not slice things. Oh, I guess before we even get that far, we'll come back over here with this camera. We'll take a little look over there. I have to put everything back together. So I'm going to turn the heat off so I don't burn myself as bad when I go to put the sock back on. I had taken the silicone sock off. So we've got heat back down to 0. You might want to go to the other camera then, I'm thinking. We're going to put the silicone sock on. The big open end always goes towards the end where the thermistor is and the heater. So we'll put that up on there like that. Be careful, it transfers heat pretty well, even though it's stopping the fan from cooling your hot end. Okay, so that's back on, and then I have to put the stock fan back on. And I'm actually going to turn it off for a second because I personally have stuck a screwdriver into the cooling fan for the heat sink, which is inside of here. You don't want to do that. It doesn't go very well. So we're going to put our fan housing back on, and then we can see about the next step here. Let that fit in there. And since they've learned about all their bonding issues or whatever, there is a bond that goes to one of these. Luke found the hotspot.
Okay.
Anyhow, there's a bonding screw that has to be hooked up on one of the fan screws, fan housing screws.
Sorry to surprise you, but here is a question here. What's the best software for creating the 3D models? I'm still new to 3D printing at Jude Nathan. So.
Okay. So everybody has their opinion on this. I personally use Fusion 360. They offer a free hobbyist license. As long as you're not making $100,000 a year off of manufacturing with their product, it's free. You do have to renew your license every year, and recently they took away a couple of the advanced user features, which I never used anyways. But so I'm having to hold on, getting the screw into place into the grounding bonding screw. Put it back together here. Okay. But anyhow, so I like Fusion 360. Some people will tell you to use Tinkercad. Tinkercad will get you going really fast. My problem with Tinkercad is I was limited by it in the first hour that I used it, actually in the first 30 minutes, but I had used CAD software before, and it's for basic stuff, and as long as you use basic stuff in basic forms, it's great, but you get limited really fast. So personally, I would go find Lars Christensen on YouTube. He has an awesome learner's guide for Fusion 360. He has projects you can do with him to learn side by side. So you load the project into your thing to look at, and then you do the project in another window, and a really great way to learn it. So if you're going to be doing this for a while and you really want to design well, go with Fusion 360. If you just want to make basic little trinkets and not put your time and energy into learning it in advanced software, use Tinkercad. Those are, in my opinion, the two main choices.
Okay. Thank you.
Yeah, no problem. I'm just sort of looking at what I need to do to run safely here. So let me move this light or this camera up here a little bit. I'm gonna show that other camera for a second. Ben?
Okay, sorry.
Yeah, it's okay. So now I've separated my wire from the PTFE, right? The PTFE is going to do its own thing. It's no longer got that kink in it that it was having right here because it was bent over sideways and whatever. So it can run free. It can run through its whole workspace without getting kinked. And I'm going to find one of my bigger arms to put on here, and we're going to hold this up. Line up a couple of questions, and then maybe what you can talk about anything that you know that you are authorized to talk about products coming out. And I'm going to see if I can grab that support real quick. Sorry, folks. I didn't know I was going to be using the overhead support on this thing. But I have an Ender 5 that was just waiting to donate one to the cause. So here we go.
Okay.
Look at that.
Okay. It's just look straightforward for this CR-30.
All right. So that's the medium size one for the Ender 5 standard and whatever. It looks like its geometry works pretty good, actually. I am going to move it over here a little bit just so that the wires don't hit the side of that when it moves. And then once I figure out where I want this, I take a zip tie and I do a sort of a figure 8 around it, and it'll stop it from sliding side to side. And for those that hadn't figured it out, that's a badge retractor. For those of you fortunate enough to be in the U.S., you can go to the Dollar Tree store. You get 3 for $1, so that's 33 cents plus tax if you have a tax state. That's pretty affordable. All right, so now we've got our wires outside of the wheel path over here. They're supported up here. They're not putting strain on our PTFE. I'm going to take a quick look what this looks like when it gets all the way into the tightest most position, just for grins. to see what the tubing does. But even at that, it's got a nice loopy loop coming in, so I shouldn't have any restrictions on the filament. So we're good to go. And we'll run it to the far position.
So 3D printing and painting set, is that your design on singular? This is same as Zenfire Plus, right?
Yeah, that overhead support thing is my design, yes.
Okay.
I will give credit. I did steal the clip-in thing from another STL or whatever, but all the rest of it's me.
Okay.
I just didn't want to have to model the plastic to go in the groove. I found somebody who'd already done it well, and why recreate the wheel, right?
Yeah.
Okay, so go ahead.
Share link so everybody to visit and see if you're interested in use it.
Yeah.
Yeah.
Okay, so now's where we run into the roadblock I warned about earlier. I have not sliced anything ahead of time to run in this, so I leave it up to you. We can close this off as the build, and then and talk a little bit more with any of the questions the users have, or we can explore together and try and follow the instructions and find the new software. And I can actually point my second camera at my laptop, and we can go see about installing the slicer and slicing something.
Okay. So look, maybe Kevin will share some few thoughts of what he experienced with this printer, and also see the time. So we already have like almost 90 minutes. So I don't know if we have time to continue, but Kevin share a little bit. If you have, then we continue. If not, we just stop here since the assembly kind of finished. And yeah.
Yes. Yes. Look. So due to the time, it's almost 19 minutes. So I would like just share one question about the experiments that I used this CR-30 yesterday. Here's I printed a rat yesterday, and as you can see, the rat at the beginning here is not very perfect, right?
Uh-huh.
Because this print this model here, it's supposed to be have a support, but when I test it, I didn't give it a support because I would like to test it. And the interesting thing is this print never failed, and it works kind of perfectly, I think.
Yeah.
Yeah.
It did a good job. So just so I know, did you print it with its feet flat on the floor?
Yes. So
okay. So one of the tricks that people are going to start seeing, at least for a little bit, for those that want to use the material, if you have something that needs really fine detail and you're having a hard time getting off the bed, you can basically print a waste block that's at the same angle as the can you show my hand down here, Ben? Sorry. You can do a support block that's at the same angle as the gantry.
Yeah.
So you got a block, and then when it's printing straight away from it, so it'll act like a traditional printer. The only thing is you're having that waste material in the block, but just think of it like supports. So if you have something really tiny and precise that you just can't get to start off with the bed, just make a little block and add it to it in the slicer, and then you can print off of a flat plane. And depending on how much plastic you want to use and how big the part is, you can do it as big as you can fit, right?
Yes. So I'm thinking the CR-30's structure is better than the other traditional 3D printers due to the 45 angle.
Okay, yeah.
Yeah.
Your eye won't be as drawn to the layer lines because they're not perfectly square to the deck. So there'll be that. And so my sort of thoughts, since we're here or whatever, I love that it has, we didn't talk about all the specifics of what I saw in this when we put it together. So on the fan cooling duct, we've got dual 4010 fan ducts. So this thing is not going to be in want for cooling, right?
Yeah.
So that's going to be good. It looks like it's got a pretty decent 4010 on the main. But yeah, I think that this thing has its place, right? Its place is going to be making things that are either really long or things for those that manufacture that want to do the same thing over and over and over again. I think it'll be really awesome because they can set it up semi-unattended and you're not having to harvest part. Obviously, in this session, we're not going to be able to test how well things come off the bed. And I'll share some feedback I got from early testing people. I wasn't in the initial beta testing, but I actually was on the phone with several of those people offering my opinion on how they could fix some things they were running into. But if everything goes well, the things that you have to watch out for, whether you're doing multiple parts or longer parts, is you're going to want really close control on your first layer so that when the part rolls off the end roller, I'm going to move the camera here a little bit. Okay, we're going to visualize a little bit with me, right? So when the part's coming along, it starts to come along. Now it's having to release from the end here. If you have too much tension there, it can actually sort of cause the belt to flex a little bit and affect the print that's going on over here by the flex of it coming off, right? So it's going to behoove you to get your first layer height as close as possible, and that will help reduce the effects of the part coming off, right? So I see that being one of the biggest things. The other part about it is we haven't come up with an exact aftermarket mod for it yet, but knowing how conveyors work, there may be people doing personal mods, not on the out feed roller, but on this drive roller. If anybody's ever used a belt sander, here in the US we have handheld belt sanders that use a belt like this, and you have a thing to track it to make it go to one side and the other. But part of their drive system is that their roller is bigger in the center than the outsides, which makes it track towards the middle if everything is adjusted right. And even though you aren't doing it at the factory, I'm pretty sure, and I'm going to work on developing this and I'll make the information available to the public when I'm ready, but I'm pretty sure you're going to be able to take sort of tape and put tape in a progressive down, go from like really wide to a little narrower and create just a baby crown right here. And that will help keep the belt tracking on the center of the bed. So this is new territory for me. Some of the other belt drive people that have done it might go, oh, that's not going to work, or it's not. This is just my thoughts on what I'm going to experiment with to hopefully have mine running at the top level, right? That's my thing, is to make it run as good as it's capable of. The other thing that we really didn't cover in the build, and this is really, you could take the stuff out of my help guide for this, is this adjusting the eccentrics on the workhead and then aligning this XY gantry on the top. That will be exactly the same as an Ender 5 series printer. It's just tipped on an angle, right? So I have guidance in there on how to align that XY bar to the main frame, and also to how to align the two shuttles to each other. That's all part of the process. But if you just basically take the XY alignment part of my guide, you'll be able to do this and get that assembly as squared up and true as possible. And then obviously you got to adjust the little eccentric wheels, and those are pretty much standard. So that's most of my thoughts on what's going on. And we probably won't, unless we decide to do a follow-up live stream, just watch for me on the Creality official user group. That's where I will put any posts I do about this machine out now that I have it and everybody knows that I have it. So if you want to keep following along, hit Creality official user group. That's where I'll be at talking about it.
Yeah, so we can now pretty much stop today. Thank you so much, Luke, for assemble printers, and tell everybody what you know about other stuff that will help them. And thank you for joining us. I think we'll calculate that if we have follow-up using of this printer. So,
yeah. So as you guys saw, I talked and fiddled around and messed around. It took me 90 minutes. Granted, I am an advanced user. Honestly, even if you take your time and really go slower, going back and forth with the video. I would be surprised if you hit the 3-hour mark. I would expect to be less than that. Not that it's a competition, but take your time. This is the most important part of owning a printer is the assembly process. If you don't have everything aligned, you might get it together fast, but it's not going to work right? So everything you can do for alignment, do. If you have time, go find my guide, learn how to align that XY gantry to its frame. Those are the things that are going to make your printer print top notch, because that's going to align here. Let me see if I can get this lined up better. Okay, so imagine along with me. If this is not perfectly planed this way, which is what my guide will have you do, because we're going to align it to this upper rail frame. When we get it perfectly aligned, we're going to get a perfect layer all the way across, right? If we don't get it aligned, you're going to have it hitting heavy here and light here, or hitting light here and not at all there, or whatever. But it has to be on plane with this. And if I can come up with a way to better align it where we're actually aligning it to the bed, I will. But I really, unless this assembly is really skewed, I'm pretty sure, I'm going to pan up here a little bit. I'm pretty sure we're going to be able to make sure that this extrusion is parallel to this extrusion, and that should be parallel to the bed. And I'll put it in the groups if I find out that there's other tweaking that needs to be done beyond that. But I really expect that to get it really close by aligning this to this.
Okay, thank you. Yeah.
Yep.
So we should say goodbye to everybody, and
Yep.
Yeah, see you next time, guys.
Yep. Thanks everybody for coming out, and happy printing.
Good night.
Good night. Bye.